it is going to be a deep dive into request allocation via threads, work managers, and how they contribute in tuning the performance. And to solve the issues related to performance bottlenecks, we will need to understand from the basics. We need to have strong foundation to understand the performance that is not only related to the not only limited to the application server, which is WebLogic, but there are multiple things we need to look into. As a middleware admin, we need to find out the causes and the impact, right? So not only limited to WebLogic, but there are other hardware and software limitations, meaning system resources, and what else? Yeah, there are many things. We'll discuss this right now. So we'll discuss about why performance optimization and in what cases we need to optimize the performance. What are the basic performance aspects in WebLogic, like thread management, JDBC connection pools, heap and garbage collection. We need to take care of stuck threads, deployment, optimize the deployment performance, JMS performance, servlet and HTTP configuration, caching and session management, JVM tuning parameters, and monitoring and diagnostics. So once you are aware of all these aspects related to performance tuning in WebLogic, then these include actually these all what we discussed, like these 10 points. So these includes a lot of things, how to collect the data, how to uh, analyze the logs, and how to analyze and assess the performance metrics, and what are the key performance indicators. And based on your analysis, based on the collected data, based on the issues and the root cause, what are the steps and instructions you are going to follow? Or if it is not in your scope, what are you going to do? So many things related to performance may not be in your scope, right? So you need to coordinate with development team and database team in order to get it resolved. So we'll see the real-time use cases, and as thread management is the basic underlying uh, concept that all starts with receiving the request from the user or any external service. So that is where it all starts, right? So we'll start with understanding what is a thread and what are the characteristics of a thread and who creates the threads actually. And we'll understand each thing separately. What are the, in what levels, what type of threads are created with a real world scenario, and we'll understand the thread life cycle and what are the hardware resources that the threads use. And we'll understand the life cycle, how the thread transitions from one state to another state. Thereafter, we will understand what are the software resources that threads use when they are getting processed, when they are processing your requests, and how these threads are allocated. So if it is Java, two scenarios, Java and WebLogic. So both have different approaches. So we'll have understand each thing with a real-time scenario. And here comes the thread pool management in WebLogic, right? So how the thread pool, what is the thread pool architecture? how does the thread pool work in WebLogic? Uh, Actually, there are different versions. In the older versions, it was different, and the newer versions, it is the approach of handling the threads and the queue is different. So we'll understand with the request flow and the thread allocation for different web resources, and then we'll discuss about common thread-related issues in WebLogic. So what is a stuck thread? And with a real-time example, this is blurred because at this point in time, it is not required to understand what is the cause and what is the resolution, right? Why? Because first we need to understand the issue. What exactly is the issue? And in order to find the root cause and the resolution, we need to gain more knowledge. So we'll come back to this later. So what are the hogging threats, the threat starvation, what are deadlocks, thread leaks, improper use of thread local, incorrect thread affinity or overload, thread pool, misconfiguration, and how to, what are the different tools and logs, uh, and how do you collect the data, and what metrics do you focus, and what is the meaning of each collected item. And in summary, for all the different types of thread related issues, we will find out what is the cause and what is the impact on each service or application, and what is the solution you are going to provide for each type of thread related issue, whether it may be in your scope or the other team. Then after we'll understand what are work managers and thread constraints. Right, in WebLogic, there are uh, different aspects in how to manage your application priorities and lock the resources for few web methods or EJBs. Right. So why use custom work managers? What happens if you don't create a custom work manager? So types of work managers, then at different scope. There is application scope, module scope, and global work manager. So we'll understand the workflow of a work manager and what are the different constraints with examples and where to configure these constraints. What does these constraints mean? We'll see with the examples, and yeah, again, understand workflow for each full work manager uh, on the deployment descriptors. We'll break down each parameter to understand the purpose, definition, use, and scope of each parameter. Then after, we'll club all these and understand how it all work together, like the execute queue, the thread pool, and how the thread pool is going to allocate its threads for multiple work managers, the custom work managers, or application scope or module scope work managers, right? So we'll take a real-time use case and we'll apply some constraints for work manager and see the effect. And finally, work managers in WebLogic, different configuration methods. Um, in application deployment descriptors, how do you define, and via admin console or config.xml, which is a master configuration file, and when to configure in what case you configure, what happens when you configure the work manager using console defined. So we'll understand this and again a real-time scenario. And finally, we will determine what are the best practices. So this is the whole agenda of, and also a deep dive into thread pool management. That is a major part in performance tuning. All right. So let us start. I'm not sure how many classes it is going to take because we are not leaving any concept or any topic behind. We'll have a 100% coverage on this one. And this is only related to thread. Again, going forward, there will be thread dump, memory management, understanding the memory architecture, different segments, and garbage collection, how the threads, we can correlate threads with uh, heap memory because both are interlinked. All right. And yeah, again, after the memory management and garbage collection, we will again focus on collecting the data related to memory and garbage collection to derive the performance metrics, or not exactly metrics, but to find out the root cause of heap related or memory related or garbage collection related issues, right? So most of the performance related issues are found based on thread dumps, heap dumps, garbage collection logs, and few other monitoring tips and tricks, right? So once we are all done with all these things, implementing, understanding the real-time scenarios with a use case, then applying the fix. So it covers a lot of things. So not only threads, memory, GC, but there are multiple things that contribute performance tuning. For example, high availability clustering, right? Load balancing, failover mechanism, and session replications, different types of session replication, and what else? Coherence, JDBC database connections, and JMS, if you have JMS implemented in your applications or project. So these all things contribute a lot in terms of performance of your application, right? So most of the part we have already discussed, like coherence, session replication, and different types, and JDBC connection pool. So now let us start with thread pools and work managers. Then we'll go for heap, memory management, garbage collection, types of garbage collection policies, and yeah, understanding the garbage collection logs, thread stacks. So there are multiple things. So for everything, we need a starting point. So let us understand from the starting point. So performance optimization is a critical